During partitioning, Unstructured produces document elements. The partitioning strategy determines what approach to use to produce the document elements. After partitioning, chunking rearranges these resulting document elements into manageable chunks. Chunking provides enhanced precision and relevance. It also provides better context for an LLM, reduces the lost in the middle problem, where RAG systems can sometimes fail to use relevant information if it's buried in the middle of a large document, and provide a lower risk of hallucination. Chunking also improves system efficiency by providing faster retrieval when smaller chunks are stored in a vector database, for example, and also to optimize computational resources, as smaller chunks require less memory and computational power for both the embedding process and the downstream generation by the LLM. During chunking, Unstructured uses a basic chunking strategy that attempts to combine two or more consecutive elements into each chunk that fits together within the max characters setting. You can also control this behavior with chunking strategies such as by title, by page, or by similarity. After chunking, you'll have document elements of the following types: composite element, table, or table chunk. Here are a few examples. This first example is a composite element, and again, document elements have a type, an element ID to uniquely identify the element, some text, and some metadata. If embeddings are generated, an embeddings field will also appear. Here is a table element that fits within the boundaries of the chunking strategy, and here are two table chunks, comprising two chunks of a larger table element. Let's talk about the various strategies now. Again, these strategies include the basic chunking strategy, as well as chunk by title, chunk by page, and chunk by similarity. The basic chunking strategy, also known as chunk by character, uses the max characters setting or an absolute or hard limit to fill out each chunk. It also uses a new after n characters setting, which is an approximate or soft limit. Let's look at a picture to demonstrate this. In this picture, we'll see the orange dash area representing a chunk. In this chunk, there are three elements. The sizes of these elements fit within the chunk. The green dashed line towards the right of this graphic indicate the new after n characters limit, or a soft limit. The red dashed line towards the right is the max characters, or hard limit. You'll notice in scenario 1 that the next element, this candidate element, exceeds both the soft and hard limits. Therefore, this element will be contained in the next logical chunk. In scenario 2, the green candidate element exceeds the soft limit, but does not exceed the hard limit. So the candidate element will be added to the chunk in the orange dotted box. However, the red candidate element exceeds the hard limit. Therefore, in scenario 2, the red candidate element will be added to the next logical chunk. And finally, in scenario 3, the first two green candidate elements are within the hard limit. However, the second candidate element exceeds the soft limit. That being said, both of the green elements will be contained in the chunk within the orange dotted box. However, after the soft limit is reached, the very next element will be automatically added to the next logical chunk, even if it does not exceed the hard limit. Now let's look at an example of this basic or by-character chunking strategy with another picture. In this picture, you'll see on the left a candidate series of characters indicated by the blue box. Now we've set the max characters as well as the new after n characters somewhat arbitrarily small at 200 so that you can see how the information is chunked. You can see on the right side as we approach 200 characters that once we hit 196 characters, we can no longer produce any more characters to fit within that chunk without going over the 200 max characters limit. Unstructured does not break off in the middle of words, for example, so it backs up and it takes the entire whole word, this, and then breaks it. You'll notice in the next chunk, starting with the word work, that the chunk size is restarted at 0 and continues on. Again, we hit 196 characters and we cannot complete the next whole word, so therefore the next chunk begins. The third chunk, as you can see at the bottom, starts with state of the art. We hit 200 characters for that chunk exactly, and so we break off at the end of that word as well. So now you can see how the basic or by character chunking strategy works. Let's take a look quickly before we move on at how this works with tables. Again, we have the 200 character limit, and as you can see in the first chunk, we go up to 195 characters, which is very close to 200 without going over. If we look at the next chunk, we notice that it's only 83 characters. And the reason we break that off is any more characters that would be added would break the table limit. And so the end of the table ends at that 83 characters. Context between chunks can also be maintained by using the overlap and overlap all settings. These repeat the specified number of characters from the end of the previous chunk to the beginning of the next chunk. Let's take a look at a picture to see how this works. In this particular picture, you can see where overlap all is set to true, which is not the default, by the way. We will overlap always a portion of the last element in the chunk and prepend it at the beginning of the next chunk. As you can see, in chunk 1, element 5, a portion is copied from that element into the overlap at the beginning of chunk 2. Likewise, in chunk 2 on element 6, part 1, this red portion is copied into the beginning of chunk 3. Notice that element 6 has both part 1 in chunk 2 and part 2 in chunk 3. The element itself exceeded the max characters setting, and so it is split into 2 chunks. However, the overlap is still preserved as much as possible within the barriers of the max characters setting. Again, notice in chunk 3, element 6, part 2 ends with that yellow portion being copied into the beginning of chunk 4. Now, this is not the default. The default is overlap all equals false. And what that means is if we have to split an element into 2 chunks, then and only then will we apply the overlap. So as you can see in chunk 2 at the bottom and chunk 3 where element 6 is broken into parts 1 and 2, the overlap at the end of part 1 is prepended to the beginning of chunk 3. Let's take a quick look at a picture and see how this happens in action. In this particular diagram, we've applied a 25 character overlap. You'd probably provide a little bit more characters than that, but again, just to show you what's going on in a simple example. You can see on the left-hand side the portions of the overlaps, and on the right-hand side you can see how, for example, promising cross-domain is overlapped from the first chunk into the second chunk. Let's now talk about another strategy called chunk by title. The by title chunking strategy attempts to preserve section boundaries when determining the chunk's contents. This primarily happens when a title element is encountered. The title is used as the section header for the chunk. We still respect the max characters and new after n characters settings, but again, we're trying to keep titles together with elements in chunks as much as possible. Let's take a look at a graphic to see how this is represented. As you can see, chunk 1 begins with a title. So does chunk 4 and chunk 6. In chunk 1, once we get to element 4, that chunk is completed because we've reached the max character setting. When we get to chunk 2 and 3, that element will be chunked into 2 chunks. When we reach the end of chunk 3 but beginning of chunk 4, we've encountered another title. Therefore, even though there's a lot of room left at the end of chunk 3, we start a new chunk for 4 because a new title is encountered. Again, you can see in chunk 5 that element 8 ends well before the max character setting. And the reason that is because the very next element that we encounter is a title. So it starts chunk 6. Taking a look at another diagram, you can see that if we have a lot of titles with not many elements coming after them, that we'll have a lot of empty space in these chunks. There's not really any empty space that's produced. Rather, we'll start new chunks a lot sooner than we would otherwise. To reduce the number of chunks, you can also use the combine text under n characters. And this attempts to combine elements into a single chunk until that limit is reached. So to create chunks that have more content in them, you can use the combine text under n chars, as shown in the following diagram. Normally, without the combined text under n chars, we would create 4 chunks, ending after element 2 and element 5. But in this case, with the combined text under n chars set, there could be multiple title elements and their child elements within a chunk. You can see it in this example. Notice in the blue box on the left, we're rapidly approaching 200 characters, and we'll start again. However, the third chunk begins with a title, 2.3 Experimental Setup. Therefore, even though we reached only 161 characters in the previous chunk, we'll stop and form a new chunk because we've encountered a new title. The chunk by page strategy uses a similar algorithm. However, instead of at the title level, we'll go ahead and chunk at the page level. Let's take a look at that. You can see, for example, there's a page break on the left-hand side as indicated by the asterisks. The words can they. If we look on the right, you'll notice a pretty small chunk containing very few characters ending in can they. The reason we broke off that chunk so abruptly is because it detected the end of a page and begins a new chunk accordingly. Finally, we have the chunk by similarity strategy. This uses a particular language model to identify topically similar sequential elements and combines them into chunks. Again, chunks will never exceed the absolute maximum chunk size set by max characters. And so not all elements that share a topic will necessarily appear in the same chunk. However, with this strategy, you can guarantee that 2 elements with a very low similarity will likely not be combined into a single chunk. You can control this level of topic similarity by setting the similarity threshold. Let's take a look at this in a diagram. In this particular diagram, we've set a rather large 1,000 character chunk limit. However, the chunks are being broken off at around 500 to 550 characters. The reason we're breaking that off is because it detects the similarity of the items in that chunk to be contained, in this case, within the paragraph level. So now you have just about everything you need to understand how to use chunking in Unstructured. To learn more, visit our website at docs.unstructured.io/UI/chunking.